In class 11 we have studied trigonometric functions, which are defined as a sine function is from R to real numbers to closed interval minus 1 comma 1. So domain is a real number and the range is minus 1 to 1. The values of trigonometric ratios for 0 degree, 30, 45, 60, 90, 180. For sine function is sine 0 is 0, sine pi by 2 is 1, sine 3 by 2 is minus 1. So the values of a sine function is in between minus 1 and 1. That's why we are written in closed interval. And the values of cos x, cos function is also lies in between minus 1 and 1. Here the domain is a real number. What is the relation between the radian and the real numbers? Consider the unit circle with center O. Let A be any point on the circle. Consider OA as initial side of the angle. The length of the arc of the circle will give the radian measure of the angle in which the arc will subtend at the center of the circle.
Gitu ini ya, itu di wisma kita. Iya. Tangi waktu start aja cepet sih, juga 10% itu berarti.
Anak kenaya itu cerita mereka lah. Ini orang. Ini dia sama dia.
Cuman pa. Here we can see that the length of the arc of the circle will give the radian measure of the angle in which the arc will subtend at the center of the circle. Every real number will correspond to the radian measure. For one real number it corresponds 1 radian. For two real numbers it corresponds to 2 radian. Thus, radian measures and real numbers can be considered as one and same. Cosine function, cos is from, the domain is real number and the range is minus 1 comma 1 closed interval. And tangent function, tan is from, so tan we write as sin x by cos x, in which cos x is not equal to 0. If it is equal to 0, it will be 1 by 0, which is infinity. So cos x is not equal to 0. Then we write this as real number minus the set of all x such that x is equal to 2n plus 1 into pi by 2. N belongs to z. So domain is this, 2, range is real number. So tan function, tan is from r minus x such that x is equal to 2n plus 1 pi by 2, n belongs to integers and range is real numbers. Then cotangent function is from r minus x such that x is equal to n pi where n belongs to z. Two real numbers, so range is real number. And secant function, so secant is from r minus x such that x is equal to 2n plus 1 pi by 2, n belongs to z, to r minus open interval minus 1 to 1. Then cosecant function, r minus x such that x is equal to n pi, n belongs to z, to range is r minus 1 comma 1 open interval. Inverse function, we know that f is from x to y such that y equal to f of x is 1 1 and onto, that is bijective function. Then we define another function g is from y to x such that x is equal to g of y, or x belong to x and y belong to y, which is also 1 1 and onto. If both 1 1 and onto function is satisfied, then inverse exists. So g is called the inverse of f, or g equal to f inverse. In such a case, domain of g, which is equal to range of f, and range of g equal to domain of f. We have seen that the sine function domain is real numbers and the range is -1, 1. Here the range of f, which is equal to domain of g. That is, we get sine inverse as the domain will be -1, 1 and the range will be real numbers. Similarly for cos, domain is real number and the range is -1, 1, and the cos inverse is domain is -1, 1 and the range is real numbers. The function g is called the inverse of f and it is denoted by f inverse. Further, g is also 1 1 and onto, and inverse of g is f, that is g inverse equal to f inverse whole inverse, which is equal to f. Graph of sin x. So sin 0 is 0, sin pi by 2 is 1 and sin pi is 0. So we have to draw this graph like this. We can check whether it is 1 1 and onto function. If we take f of x1 equal to f of x2 equal to sum 1, so sin pi by 2 is 1 and sin 5 by 2 is 5 pi by 2 is 1. So f of x1 equal to f of x2, so x1 is pi by 2 and x2 is 5 pi by 2. So we say that x1 is not equal to x2, then it is not 1 1 function. If we take any values in between these two, if we take this as x1 and this as x2, so f of x1 is equal to f of x2 and x1 is not equal to x2, so it is not 1 1 function. Now let's check for onto function. Onto function means if every element of y is an image of some element of x under f, that is, for every y belong to y, there exists an element x in x such that f of x equal to y. If we take any values between 1 and -1, let's take any value y, any point on in between 1 and -1. If we take this, then xn will be some other point. If we take any point on y in between 1 and -1, then it will be some point on x. It implies that every element of y is an image of some element of x under f. Then we say that this function is onto. Sine function is not 1 1 but onto. It is not bijective function, but it is restricted on domain and ranges of trigonometric functions, which ensure the existence of their inverses. If we take this span, that is from -pi by 2, pi by 2, we can prove that this is 1 1 and onto function. 1 1 means for every element of domain which have an image, distinct image in range. Here we can see that for different value of x, we have different value in f of x. If we take any value on x, it corresponds to f of x. So every element, distinct element in domain will have distinct element in range. Sin is from real numbers to closed interval minus 1 comma 1 sin x equal to y. That is, sin is from minus pi by 2 to pi by 2 to minus 1 to 1. So sin x equal to y, which is bijective function. So sin inverse is minus 1 to 1 and the range is minus pi by 2 to pi by 2. That is, sin inverse of y equal to x. That is, domain of G equal to range of f and range of G equal to domain of f. That is, range is becoming domain of sin inverse and domain is range of sin inverse. That is, sin inverse of y equal to x. If y equal to f of x is an invertible function, then x equal to f inverse of y. Thus, a graph of sin inverse function can be obtained from the graph of original function by interchanging the x and y axis. That is, if AB is a point on the graph of the sine function, then BA becomes the corresponding point on the graph of inverse of sine function. The graph of an inverse function can be obtained from the corresponding graph of original function as a mirror image along the line y equal to x. Here, this portion of the graph of y equal to sine inverse of x represent the principal value branch, that is from minus pi by 2 to pi by 2. So sine inverse is from minus 1 to 1, which is domain, and the range is minus pi by 2 to pi by 2. This is called the principal range. The branch with range minus pi by 2 comma pi by 2 is called the principal value branch.